on topic of Bernoulli's equation. So let's take a look at the question. Water flows into a large tank at a rate of 0.11 meter cube per second. So now here, there is a typo here. So it should be meter cube per second. The water leaves the tank through 20 holes in the bottom of the tank. Here we have 20 holes. Okay, and each of the holes, the diameter is 10 mm. Now we have to determine what is the height, the equilibrium height for the steady state operation. When it mentions about steady state operation, it shows it means that the flows in is equivalent to flows out, or mass flow in equal to mass flow out. There would be no accumulation. Now, when in this question mention about the water flows, and then you are required to find pressure or velocity or height, you will use Bernoulli's equation. Normally, they will ask about velocity and pressure, but in this question, we are required to find what is the elevation or the height of from point surface of the surface water of the tank inside, the fluid inside, water inside the tank, to the flows at 20 holes. Okay, now this is our boundary. Okay, we have to select the point where we want to apply the Bernoulli's equation, and at this point I will not apply my Bernoulli's at here, point 1. My point 1 would never be at here, because this point is not continuous or not in a streamline. Okay, so I will never ever choose this point. Okay, what point that I will choose is at the surface of this water. This would be my point number 1, and point number 2 is at the outlet of this tank where the 20 holes located. Now I will apply Bernoulli's equation at point 1 and point 2 in order for me to determine what is the elevation of this tank. Okay, water in this tank. Okay, now let me change and color. Okay, we have to apply Bernoulli's equation. So Bernoulli's equation is P1 over rho G plus U1 square over 2G plus Z1 equal to P2 over rho G plus U2 square over 2G plus Z2. So now I already wrote down Bernoulli's equation at point 1 and point 2. This is the total energy at point 1 and total energy at point 2. Now we have to take a look at one by one, the pressure energy term, kinetic energy term, and pressure potential energy term. So in this equation, we are using head. So let's take a look at the first one, is a pressure head. Okay, I've already select point number 1 and point number 2. Point number 1 is open to atmosphere. Therefore, P1 is equivalent to P atm. What about P2? P2, this flow will flows out to the atmosphere. Therefore, point number 2 also will be P atm for the pressure. Therefore, in this question, we will cancel out the term pressure energy 1 and pressure energy 2, since P1 equal to P2 equal to P atm. So Bernoulli's equation only involves pressure, gauge pressure. Okay, for the pressure at the end, we will zeroing it. Okay, next we take a look at the kinetic energy term, U1 and U2. Okay, U1 square over 2g and U2 square over 2g. So for U1, we are assuming that the velocity at point 1 is equivalent to 0. Why? Because this is a steady state operation. Therefore, point 1 will not going up or going down, increase or decrease, and it will maintain at the same position or level during the process. So point number 1 is equivalent to 0. Why? Because it will not be increased or decreased, maintain at that position. Okay, the velocity at 1 is equivalent to 0. Okay, 0 meter per second. Therefore, we can cancel out U1. What about U2? U2 cannot be 0. Why? Because this is the outlet of the tank where the 20 holes located. Therefore, there is a velocity there. Okay, if we are assuming that velocity at point 2 is 0, therefore there will be no water comes out or flows out from that hose. Okay, so what about Z1 and Z2? Z1 and Z2 is elevation for point number 1 and elevation for point number 2. I always use Z1 and Z2 as a point Z1 and point Z2. Now, we rearrange this equation, so we will get Z1 minus Z2 equal to U2 square over 2G. Now we take a look at Z1 and Z2 terms. I draw it here. So here we have 20 holes, and up here we have point number 1. So this is my point number 1. This is point number 2 with the elevations of H. Okay, different height. Now, if there is two ways, if you choosing point number 1 as your datum, so if I choose point number 1 as a datum, okay, and I will make it 0 meter. Then what about Z2? Okay, if you chose point number 1 as a datum, take a look at point number 2. Point number 2 is H meter below than point number 1. Therefore, when below than number 1, you have to put negative H meter. Okay? So that is number 1. If you chose Z1 as your datum. What about if you choose Z2 as your datum? Now I chose Z2 as my datum, and this will be equal to 0. So Z2 is 0. Therefore, Z1, take a look at Z1. So Z2 is 0. Z1 is H meter above point number 2. Therefore, you will substitute Z1 as H plus HM, H meter. Now I will take point number 1, which means step number 1, if I choose Z1 as a datum. Now Z1, my Z1 is a datum, therefore I substitute Z1 here, 0, then minus, follow this equation, and then open the bracket. This Z2, here is Z2, Z2 is negative H, therefore you substitute here, negative H equal to U2 square over 2G. Okay, So in order for you to determine what is the value of h equal to u2 square over 2g. Now you have to determine what is the velocity at point number 2. Now let's calculate velocity at point number 2. So we already been given with the value of q, discharge, equal to 0.011 meter cube per second. Now this is our discharge. Now we want to find what is the velocity. With this value, we know that the system is at steady state. When at steady state, there will be no accumulation. So which means whatever Q that flows in, it will be flows out. Whatever value in will be out. So which means here Q in is equal to Q out. So if I say that Q in is Q1, Q1 will be the same as Q2. Okay. Now my Q1 is 0.011 meter cube per second. Therefore Q2 also the same. Now to find what is the velocity, we know that the equation for Q2 is U2 times with A2. Okay, now take a look at this. If we are considering only A2, only one hole, that means this velocity is represent for one hole. Okay, for example, if you calculate this, you are only considering one hole. Okay, if you have two holes here, 1 and 2, two holes, therefore you have to put 2 here because there will be 2 holes. If you only calculate one hole, that means you are not averaging the values of velocity here. Now what we are going to do is Q1, sorry, not Q1, Q2. Q2 equal to U2. We have how many holes? 20 times with A2. So we are trying to find what is the average velocity for that 20 holes. Every hole, how much velocity flows out from that holes. Every hole, what is the velocity? Okay. Now we find A2. So A2 is a cross-sectional area. Cross-sectional area where we know that if we take a look at the bottom, so the holes will be in circular shape. So we will use this equation, pi d squared over 4. So substitute pi. The diameter of holes is 10 mm. 10 times 10 minus 3 meter square over 4. Therefore, you will get 7.854 times 10 to the power of minus 5 meter square. So you already get the cross-sectional area. Then we have to substitute into this. Let me rearrange this equation first. So U2 is equal to Q2 over 20 A2. So I will substitute the value of Q2 U2 is 0.011 meter cube per second divided by 7.854 times 10 to the power of minus 5 and times with 20. So I will get the value for U2 is 7 meter per second. So this is my value for U2. Now we already get the U2. Then we have to substitute into this equation in order for us to determine what is the value of H. So previously we already derived equation for H equal to set to So H is equal to U2 square over 2G. Substitute the value of U2, 7 meter per second, square divided by 2. Value for the gravitational acceleration is 9.81 meter per second square. So therefore, you will get the value for H is 2.4994 meter or 2.5 meter. So you already answer your question. Okay.